problem 3.12. Consider the sequence defined by a sub n plus 1 is equal to the square root of 1 plus 3a sub n minus 1 with a sub 0 equals to 1/2. Okay. First, prove that the sequence has a limit and find it, and then second, compute the limit of a sub n plus 1 minus 1 over a sub n minus 1 when n goes to infinity. Okay, so let's start with a. This is a very similar problem as we have done before. Okay. So as usual, we assume that the sequence has a limit first. Okay, so let's call it a. A is the limit when n goes to infinity of a sub n. And let's compute it. What are the possible values of a? Well, we take limits in both sides. And then the limit of this minus 1. So this is a is 1 plus 3a minus 1. And then we have a plus 1 is equal to the square root of 1 plus 3a. We square both sides, so then we have a squared plus 2a plus 1 is equal to 1 plus 3a. 1 and 1 cancel each other out, and then we have a squared minus a is equal to 0, and then so we have a times a minus 1 is 0. So it's either a equals 0 or a equals 1. Okay, so a can have two possible values. One of these two, okay? Now, how do we prove that this thing is true? That the sequence is going to have a limit. Again, we need to say that it's bounded and that it's either increasing or decreasing. So I'm going to try and prove first that the sequence is bounded by 0 and 1. Okay, a sub 0 is greater than 0. Again, using induction. Okay, a sub 0 is greater than 0. Yes. Assume a sub 1 is greater than 0. Now what happens with a sub n plus 1? Well, this is square root of 1 plus a 3 times a sub n minus 1. Well, this is greater than, assume this is greater than 0, this is greater than the square root of 1 minus 1, which is 1 minus 1 equals 0. So a sub n plus 1 is greater than 0. Proven. Now, is a sub 0 smaller than 1? Yes. Assume a sub n is smaller than 1. What happens with a sub n plus 1? Well, this is like this again. We assume this is smaller than 1, so this is smaller than the square root of 1 plus 3, which is 4. Square root of 4 is 2. 2 minus 1 is 1. So a sub n plus 1 is smaller than 1. Okay, so we have just proven that the sequence is between 0 and 1. Now, is it increasing or decreasing? Well, a sub n plus 1 is 1, the square root of 1 plus 3an minus 1 minus an. Now I'm going to multiply by the converse and divide, so we have square root of 1 plus 3an plus and then 1 plus an. Okay, and in the numerator we have the difference of the square, so this is 1 plus 3n minus, and then this is minus 1 plus an, so the difference of this is squared, so this is an squared plus, minus 2an minus 1. Okay, 1 and 1 cancel each other out, and then we have an minus an squared, and then 1 plus 3an plus 1 plus an. Okay, and we can rewrite this like an 1 minus an. A sub n is greater than 0. Okay, so this factor is going to be greater than 0, and a sub n is smaller than 1, so this factor is going to be positive as well. And the numerator has all, the denominator has all positive terms, so all of this is going to be positive. So the sequence is increasing. Okay, so we have a bounded sequence that is monotonically increasing. So the limit, it has a limit, and the limit starting with 1/2 is 1. Okay. Now the second part of the problem, compute the limit of a sub n plus 1 minus 1, a sub n minus 1. Now we have the limit of this is 1, so this is 1 minus 1, 0, and then 1 minus 1, 0, so this is 0 over 0. Okay, you could say, oh, this is a great case for using Stoll's theorem. And maybe you could, but I think this is going to complicate things. What actually, the easiest way to do is to operate and substitute the expression for a sub n plus 1 with this expression, okay? And then we have a sub n minus 1. And now again, just like before, this I'm gonna say, well, this is minus 2, okay? I'm gonna multiply and divide. This is the limit when n goes to infinity, a n minus 1. I'm gonna divide by the square root of 1 plus 3 a n plus 2. And then so if I multiply this by this, what I get again is the difference of the squares. So the difference of the squares here is 4, and so we have the limit when n goes to infinity of 3an minus 3 and then an minus 1 square root of 1 plus 3an plus 2. Okay? Now 3 times an minus 3 is just 3 times this. Okay, so this and this go out and you have 3. And so then you have the limit of this, and the limit of an is 1 as we saw, so the limit of the denominator is 1 plus 3, 4, the square root of 4 is 2, so then you have 2 plus 2, 4, so the limit is 3/4. Okay, and that's it.